Okay, so let's make ourselves an OpenRocket model from scratch, starting now. So if I open OpenRocket, basically there won't be any content there. So let's just say that I want to make a 4-inch diameter rocket, and I'm just going to make it sort of gut feeling about what looks right. Okay, so here we go. Starting from the top. The top of the rocket is called the sustainer. The bottom of the rocket will be called the booster. So the booster is where the motor goes. We're going to build the rocket from the top down. So if I click sustainer, what do I want to put in my sustainer? And the first thing I want to put in is a nose cone, right? Here it is. And it says, what kind of nose cone do you want? And I say, I want a nose cone chosen from a database. And then if I click the outer diameter twice, I can get it to be listed in biggest to smallest nose cones. And I'm particularly interested in a 4-inch rocket. So let me just assume that I have chosen this one here, this Public Missiles 4-inch nose cone. And once I have chosen that, that comes up here as a selectable nose cone. And there it is. So now I have a nose cone. That's good. Of course, the nose cone doesn't fly well because it's unstable. Its center of pressure and the center of mass are not properly related. And of course, this particular nose cone is, let's see, polystyrene. That's actually probably right. So I say, oh, I'm going to click automatic. Automatic just says, that's bad. I don't want to click automatic. Automatic is going to help me make the parts fit one another. Okay, so close. The next thing I want to do in the sustainer is I want a body tube, an upper body tube. So I choose an upper body tube, and it's already starting to draw one over here. Notice that it's drawing one that's the right diameter. That's good. I just need to make it a reasonable length. So here's what I'm going to do. Let's just make the upper section until it looks good. There it is. I didn't even look at the number. I literally dragged the slider until I thought it was okay. Okay, so it looks like I chose 26 inches for this particular body tube. And the body tube, let's say that it's blue tube. Turns out blue tube is choosable. And I will say, okay, there it is. Now I want a coupler. The coupler is going to keep the upper section and the lower section lined up, right? So if I click on the body tube, then it says, now what do you want to add to the body tube? And the answer is I want to add a coupler. So here it is, coupler section. And it will automatically add a coupler at the very right end of the body tube. And the coupler really needs to be at least, twice as long as the diameter. So where's my length? There it is, my length. I want to make sure that this is a 4-inch rocket, so I have at least an 8-inch. No, I'm going to go for a 10-inch coupler section, and then I'm going to drag it down so it's half in the upper section and half in the lower section approximately. A little bit farther than that. 5 inches. I guess I can type the exact number. There it is. And this will be made of blue tube as well. Okay. Now is the lower part of the rocket, literally. Okay. And so what I'm going to do is I'm going to click new stage. This is a separate piece of the rocket. Okay. So this is called the booster section. Close that. And what do I want to put in the booster section? And the answer is I want to put in a body tube. And the body tube should match, and it does. It's going to be blue tube. Here we go, blue tube. And let me just make it some reasonable length. How about that long? Why not? Okay. Close. What should I do with my body tube? What else? What other parts? Help me out here. Does that look like a completed rocket? I need a motor mount tube. Okay, so that would be considered an inner tube. I'm going to click inner tube. And it's going to ask me, what kind of inner tube do you want? And the answer is I want a 54 millimeter diameter motor mount tube. So if I go to the database here, I can look at the descriptions, and let me just choose this 54 millimeter diameter one here. And it draws it 48 inches long. I probably don't need it that long. So let me make it shorter. So here's the length. I could probably get away with maybe about a 10-inch or so motor mount tube. And that's the right place. It's touching the bottom of the rocket. That's a good place for it. And what is this made of? And the answer is this is actually made of blue tube as well. The motor mount tube material I'm going to give you is all blue tube. Good. Fine. What else do I need on my rocket? Fins. Ah, yes, fins are important. Good. Okay, so let me go and choose. How about I choose trapezoidal fins? And so it's just going to draw some really weeny fins. That's not at all what I want. So I'm just going to take those fins and I'm going to make them taller. How about I make 4 fins instead of 3? How about I say that the root has to be longer? How about I say that the tip has to be longer? And it's not showing the tang, but it's paying attention to the fact that there's a tang. And here's one small problem, and that is I don't have a place for my centering ring underneath aft of the fins, right? Because the fins are right at the bottom of the rocket. So I might have to take these fins and at least push them forward up the rocket a little tiny bit, right up there, just to make sure I have a place for my centering ring to go in. Okay? And then there's also a space for my centering ring to go in above the fins as well. Good. What is the material of my fins? Let me go with maple. It's a wood. Let me go with thickness 0.25 inches. And I say close. There it is. Those are my fins. They're not fancy, and you might be cooler than that, but I need fins. That's true. Okay, and let me stop and show you that I can actually look at this different ways. This is the side view. Here's the back view. Here's the 3D view. Okay. Here's the finished view, so you can't see inside the rocket. But anyway, OpenRocket allows you, and I can even take this and drag it around, right? And so this allows you to make some very cool pictures for your reports if you want to. But let me go back to the side view. And how am I doing on my stability? Right now I have 3.32 calipers. Is that reasonable? That's okay, but I don't have a motor in there. It might get worse when I put a motor in there. Let's finish some parts here before we put a motor in there. What else do I need? Help me out. Yeah, let's put some centering rings on that motor mount. Okay, so here it is, the inner tube. I want a centering ring. So the centering ring will go from the inner tube to the outer tube. Let me say that those are made of maple. Let me say that those are also 1/4 inch thick. And I screwed up. Basically, I drew the centering ring on the inside of the inner tube. I was thinking it was going to draw on the outside, so I'm going to erase that. Delete. Apparently, I need to draw my centering rings, click on the body tube and say centering rings, and then it'll go from the body tube to the tube that's inside of it. Maple, 0.25 inches thick. And notice it drew it way down here, okay? And that's actually a good place for it, but I need a second one that's not way down there. So I'm going to draw a second centering ring and same details, maple 0.25. And this one I'm going to drag up to the top. Well, what I'm doing is I'm moving it around here, and I just want to put it up here at the top of my motor mount tube instead of the bottom. For your rockets, you'll probably have 2, maybe even 3. If you have that really, really long motor, you'll definitely want to have 3 centering rings at least. Okay, that's good. Oh, sort of related to centering rings are bulk plates. I need to have some plates that completely close off my av bay, both top and bottom. So I protect my electronics that's inside, right? Okay, so let me go back to my, my coupler. And let me put a bulk plate, bulkhead. And I'm going to make that also maple. All of the wood I bought is 0.25 inches thick, so it's kind of boring. There it is. There's one bulk plate at the bottom of the coupler. Let me put another bulk plate at the top of the coupler. Same details. 0.25 inches, but this one I'm going to drag it up to the top. So now I have one bulk plate at the top and one bulk plate at the bottom of the coupler. Before I put a motor in, I do need a few other things though. You can put a lot of details in here. For instance, we probably should put a weight of the av bay, because the av bay right now is empty, but you're going to put a bunch of stuff in it. And when we put a bunch of stuff in the av bay, it might move the center of mass around. So let me just say the tube coupler, I'm going to add into that a mass component. And so I drew it as a little dotted drawing here, and I'm going to say 8 ounces. And I don't know if that's right, but it's not impossibly wrong. And so eventually when you really build it, you might say, oh, it was really 9 ounces. That's okay. I'll just go and fix that. Now I just have to maybe put it in the middle. But notice I'm drawing it from the top of it, moving it from the top of it to the middle of the Av bay. 8 ounces, more or less centered on the Av bay. That's appropriate. And I'm going to call this component name electronics, just so it looks more reasonable in my list of things. What am I missing? Talk to me. I'm missing a parachute. Let's put in a drogue parachute. So the drogue parachute goes in the upper section or the lower section? Drogue. Drogue. The drogue parachute goes by the motor. The drogue parachute is what comes out first, and then it's the main parachute in the upper section that is not related to the motor at all that opens just before you land. Okay, I need to put the drogue parachute in the lower section. Okay, so here's the lower section. Here's my parachute. Let's just say that I'm going to have a 18-inch diameter parachute. Let's say that it has about 18-inch long lines on it. That's fine. I could probably grab a parachute out of a library. I'm not going to bother. And let's say that this parachute, when I stuff it into here, takes up 2 inches worth of space. So its length, packed length is 2 inches, and its packed diameter is 4 inches. Okay. So now it's drawn the parachute. And now I just have to put the parachute at the right spot. Where does this parachute go? And the answer is not inside the Av bay. That's a bad place for it. The parachute should go down here, right? Next to there, right? Make sense? Way down there? Fine. And I want this parachute to go off at apogee, or to come out at apogee. While I'm down here, let me go ahead and put some shock cord in as well. So let's say that I have maybe 12 feet of shock cord. And let's say the shock cord is tubular nylon, maybe 14 millimeter tubular nylon. And let's say that it packs down to about 3 inches long and about 4 inches wide. I'm sort of making these up, but these are not impossible numbers. And of course, the shock cord also needs to be down close to the parachute. So I'll just put the shock cord right on top of the parachute. So both of those are pretty much deep in the lower section. Fine. Upper section, now what? What do I need? Parachute up there too. Should this be an 18-inch parachute? No. How about 48 inches? I don't know, but it needs to be much bigger. Okay. So let's just say that that parachute also has its shroud lines are about the size, the diameter of the parachute. And let's say that if you have a 48-inch parachute, maybe it takes 4 inches worth of packed length and then 4 inches worth of diameter. That's the full diameter. Okay, so now it drew it way up here at the top of the upper section, and I just need to drag it down. So it's at a more appropriate place, perhaps right about here, right above the Av bay. Okay, and then I need some shock cord in there too. So let me put in my body tube, my upper tube, I'm going to put some shock cord, tubular nylon, maybe about 12 feet of that as well. These are kind of approximate numbers, but and let's say we already agreed the 12 feet packs into about 3 inches by 4 inches or so. And I just need to push that down to a reasonable spot, maybe right about here. So it looks like I've got, if these are at all reasonable sizes, I've got plenty of space in my upper section for that bigger parachute. You could make the upper section shorter, maybe. Okay. How am I doing on my stability? 3.26 right now. That's healthy. That's still healthy. It's going to get worse though when I put a motor in it. Let's put a motor in it. You could put a few more things in like eye bolts and stuff, but this is enough for now. Let's go ahead and put a motor in it. First of all, the first thing I have to tell it is which of the tubes, there are 3 tubes there, which of those is the motor tube? And the answer is the inner tube is the motor mount. So I have to click inner tube, and only after I do that does it allow me to choose a motor. Okay, so I say new configuration, and then I say select motor, And let me try saying, it could be a motor from any manufacturer. And let me try J293. I think that's one of the ones that we're going to be flying. J293, Cicerone technology. And if I say okay, turns out it's a 54 millimeter diameter 2-grain motor. And so it fits nicely. And the what happened to my static margin? Went from 3.2 down to, you read it? 1.6, 1.7. Is that still okay? That's probably still okay. Good. Let's fly it. So I go to flight simulations, new simulation, 72-inch rod, 4.47 miles per hour wind speed. That's what it just starts with. I'm okay with that. Simulate and plot, new axis, lateral distance to see how far it drifts, plot. Ooh, that's not what I expected. The reason is I told it that one of the parachutes comes out of the apogee and I forgot to tell it what the other parachute is supposed to do. Let's go back. So here I see that it gets to apogee at 3,000 feet or so, and then it comes down under one parachute the whole way, probably because I didn't tell it to pull the other parachute. That was a mistake. Let's go fix it. So go back to rocket design. This is the upper parachute. Let me edit that parachute. Oh, I need that parachute to come out at a specific height on descent, maybe 500 feet. And then this particular motor, if I go back to motor configuration and take a look at this motor, it says ejection charge delay 3. That's silly. This is a 13 motor. I'm just going to type 13. On the other hand, I'm not actually having it make use of that value. So here we go. Let me try simulating this again. New simulation. Everything is still the same. Simulated plot. Everything is still the same. That looks much healthier. See that it lands slower? Basically at 500 feet, it pulls the second parachute and lands slower. Still gets to about 3,000 feet. I'm okay with that. Last thing I'm going to do is I'm going to take a quick look at these numbers. I see that it comes off the rod at 55.3 feet per second. Is that healthy? I want that to be at least 45. Okay, so that's healthy enough. It gets to 3,100 feet for apogee. The velocity at deployment, that's a little weird, 63 feet per second. I was hoping that was going to be 0. Let me go back to this parachute, edit this parachute, deploys at apogee. I'm a little surprised by that. Anyway, well, hey, I got some work to do. That's okay. Basically, it tells me an optimum delay of about 10 seconds and basically acceleration, maximum acceleration, time to apogee, things like that. Hit the ground velocity 22. Look at that. 63.1 feet. That's before I pulled the second parachute. I forgot, remember? And then I slowed that down to 22 feet. That's much healthier, right? That's it. That's how you draw a rocket from scratch using OpenRocket. Questions? Okay.